Hello everyone. In the previous videos, I have discussed Newton method for the root finding problem. In this video, we will discuss the same Newton's method but for system of nonlinear equations. Generally, system of equations is a set of two or more equations that share a common set of variables. These system of equations can be linear or nonlinear. For example, system of linear equations let it be 2x minus 3y plus 4z equals to 4, 2x plus 3y is equals to 2, x minus 4y plus z equals to 0. This is my system of linear equations. And if we wish to convert this in the matrix form, it would be like 2, 2, 1, minus 3, 3, 3, minus 4, 4, 0 and 1. Since there are three variables, so x, y, z, and on the right hand side it becomes 4, 2 and 0. Similarly, system of non-linear equations be 2x square minus 3y plus z to the power 4 is equals to 0, 3y square minus 2z equals to 1, 5x minus z equals to 2. Finding the solution for the linear system of equations is quite simple. Let us discuss how to find the solution for the system of non-linear equations. Before that, we must know one more concept, which is Jacobian matrix. The Jacobian matrix is a matrix of all first order partial derivatives of a vector valued function given a function f from Rn to Rm, the Jacobian matrix where each element j I comma j is given by j is equals to partial derivative of fi with respect to xj. For example, find the Jacobian matrix of f1 is equals to x square minus y plus 1 minus 1 and f2 x minus y square plus 1. For the Jacobian matrix, the entries will be partial derivative of f1 by x, partial derivative of f1 with respect to the second variable, and partial derivative of f2 with respect to first variable, partial derivative of f2 with respect to second variable. This becomes 2x and minus 1 here, 1 and minus 2y. Now recalling the Newton's method, which says that we have to update the elements as xn minus f of xn by f dash of xn, and the stopping criteria be when the mod of xn plus 1 minus xn is less than tolerance. Now we will use this same Newton's method and apply this on the system of equation. But the difference between simple Newton's method and Newton's method for system of equation here is that in the left hand side we have xn plus 1, which is one value only, but in system of equations we will have this as a vector, and in Newton's method f of xn is my function directly, but in system of equation it will be a matrix. When it will be a matrix, then this term will be a problematic term. For the system of nonlinear equations, we will have equations in the form of f of x equals to 0, where this value x will be a vector containing all the variables, and this f of x will be matrices of all the functions in n variables. So, in Newton's method for system of nonlinear equations, xn plus 1 will be my vector containing n variables, so will contain my xn, and here f of xn will be my matrix. But in Newton's method we have to divide this term with the derivative of f of x. Since this is matrices, and in matrices for derivatives we use the term Jacobian. Since it is in denominator, so we can multiply it with the inverse of Jacobian of xn. Now this equation will be used as the iterative process for the Newton's method for non-linear system of equations. We can manipulate this equation number 1 as xn plus 1 minus xn, which is equals to negative of inverse of Jacobian of xn into f of xn, and we can pre-multiply by Jacobian of xn let xn plus 1 minus xn be my yn. Therefore, this equation becomes Jacobian of xn into yn is equals to negative of f of xn. This be my equation number 2 and will be used as the iterative process for the Newton's method for non-linear equations. Let us understand this method with the help of an example. The question says to solve the system of non-linear equations with the help of Newton's method, where the initial approximation to this problem is already given. Here we are given that f of x is equals to, since we have 3 equations, so this will be a 3 cross 1 matrix with entry as let this be my function 1, this be function 2, and this be function number 3. The next thing for the Newton's method is to find the Jacobian matrix for this system. The Jacobian matrix will be partial derivative of function 1 with respect to variable 1, partial derivative of function 1 with respect to function 2, variable 2, partial derivative of function 1 with respect to variable 3. For the second row it will be partial derivative of second function with respect to first variable, partial derivative of second function with respect to second variable, and partial derivative of second function with respect to third variable. Similarly, third row will be and the value of this Jacobian matrix will be this matrix. Now, starting the iterative process, we have to use the updating rule as Jacobian of x naught into y naught is equals to minus of f of x naught, where the value of x naught is already given in the question as 0.1, 0.1, minus 0.1. Therefore, Jacobian matrix value will be 3, 0.2, minus 0.099, 0.00009 minus 32.4 minus 0.0990. This value will be same, 0.0009, and last 20 into y naught is equals to the matrix minus 0.1999 minus 2.2698 and 8.4620. From here we can find the value of y naught by multiplying the inverse of the Jacobian matrix on both sides, whose value is, and we know the value of y naught is x1 minus x naught. For the next iteration we need the value of x1, and we already know the value of x naught here, which is 0.1, 0.1 and minus 0.1, and from here we can calculate the value of x1, which will be 0.4996, 0.01946 and minus 0.5215. This will be my updated value of x, and we will take the input as x1 for the second iteration. That is, for the iteration number 2, updating rule will be x1 into y1 is equals to minus of fx1, where the value of x1 will be 0.49986, 0.10196 minus 0.5215. Continuing this process till 5 iterations, we will get our desired results. I hope you have made an understanding of this part. In the next video, we will try to make an understanding of this method in a better way using the MATLAB code. Happy learning!